Hello friends, welcome to the third video tutorial of the chapter Time and Distance. In this video tutorial, we will be discussing two seemingly difficult questions and their possible solutions applying different methods. We at the same time request you to follow only the method that suits you best while taking an exam. So here we are with the first question, the language of which goes like: the distance of the office from Mr. Iyer's home is 80 km. One day, he was late by 1 hour than the normal time to leave for the office. So he increased his speed by 4 km per hour and thus reached office at the normal time. So what is the changed or increased speed of Mr. Iyer? The given options for this question are 20 km per hour, 28 km per hour, 30 km per hour and 40 km per hour. Now let's try solving this question applying the traditional method. If we are to put the given pieces of information into an equation, the equation will be like time old minus time new is equal to 1. As Mr. Iyer was taking 1 hour more in the first scenario, which means time old is greater than time new by 1. Now as we know that time is equal to distance upon speed, so we can write the equation further as distance upon speed old minus distance upon speed new is equal to 1. Now we know that the new speed here is actually the increased speed of Mr. Iyer, and now we can use hit and trial method to solve the equation to find the required distance. So on putting 20 km per hour, which is the option A, in place of new speed, we get 80 upon 16. Here in the denominator part we have got 16 because it's given that the new speed is increasing by 4 km per hour, which means the old speed must be 4 less than the new speed. So if new speed is assumed as 20 km per hour, old speed would be 16 km per hour minus 80 upon 20, and this whole left hand side is equal to 1. Now solving the equation further, we get 5 minus 4 is equal to 1, or 1 is equal to 1. Hence it's clear that 20 km per hour as an option satisfies the equation. Thus 20 km per hour is the right answer. So wasn't it simple? Now the next method to solve the same question is a very important shortcut approach, which goes like product of speeds is equal to distance into difference in speed upon difference in time. Friends, I must say this is a very important formula or shortcut approach for time and distance questions. We can also write it as S1 into S2 is equal to D into difference of S1 and S2 upon difference of T1 and T2. And to remember the formula, just do remember the basic relationship between time, speed and distance, which is speed is equal to distance upon time. You can observe here that when we are to put product of speeds on LHS, we have taken distance as numerator and difference of time as denominator in RHS, which means you just need to remember the placement of difference in speed. Now let's come back to the question. So on putting the given values in the formula, let's see what we get. S1 into S2 is equal to distance, which is given as 80 km, into difference of speed, which is 4 km per hour, upon difference of time, which is 1 hour. Therefore S1 and S2 is equal to 320. Now we know that if S2 is 4 km per hour more than S1, we can write the equation as S1 into S1 plus 4, which is S2, is equal to 320. Here we need not solve necessarily quadratic equation. We can just try and find two factors of 320 in such a way that one factor must be greater than the other by 4. So the possible factors are 16 and 20, and thus we can mark S1 as 16 km per hour and S2, which is the increased speed, as 20 km per hour, and which is the correct answer. So wasn't it simple? I hope it was. Moving forward, let's take the next question, the language of which goes like: Amir, when increases his speed from 24 km per hour to 30 km per hour, takes 1 hour less than the actual time to cover a certain distance. What is the distance covered by Amir? The given options for this question are 90 km, 120 km, 140 km and 150 km. Friends, we can again solve this question applying different methods. Here S1, which is the initial speed, is equal to 24 km per hour, and S2, which is the speed in the second scenario, is equal to 30 km per hour. Here you can see that the actual speed is increasing by 6 km per hour, and in fraction we can write increase in speed as 6 by 24 or 1 by 4. Therefore, while applying the concept of constancy, which we discussed in the first video tutorial, we can find decrease in time, which will be 1 by 5 and which is equal to 1 hour as given in the question. Therefore, the actual or the initial time is equal to 5 into 1, which will be 5 hours, and therefore the distance covered is equal to initial speed into initial time, and on putting the values we get 24 into 5, which is equal to 120 km, and that's the answer. So wasn't it simple? Now the same question can be solved applying the shortcut approach we discussed previously in this video. The formula says S1 into S2 is equal to distance into difference of speed upon difference of time. So once again, on putting the values in the formula, we get 24 into 30 is equal to distance into difference of speed, which is equal to 6 km per hour upon difference of time, which is equal to 1 hour. Now on solving the equation further, we get distance is equal to 120 km, and that's the answer. So wasn't it simple again? By now we have explained two methods to solve this question. Let's discuss another method to solve the same question, and this one is the traditional one. We know that the speed of Amir is increasing in this question, and therefore he is taking less time in the second scenario, which means he took more time in the initial scenario. Therefore, we can write the equation as time old minus time new is equal to 1, and we can further write the equation as distance upon speed old minus distance upon speed new is equal to 1. On putting the values, we get distance upon 24 minus distance upon 30 is equal to 1. Now instead of solving this equation, we can apply the hidden trial method by first picking the option which is completely divisible by the denominator parts of LHS. So one such option here is option B, which is 120 km. So on putting 120 on LHS, we get 120 upon 24 minus 120 upon 30. It should be equal to 1. On further solving the equation, we get 5 minus 4, which is equal to 1, and which is equal to the RHS, and hence 120 satisfies the equation. So friends, this is it. In the next video, we'll be taking some more complex looking questions and we'll discuss their possible solutions with different methods. So till then, keep learning and have a great time.